Today we're going to talk about energy. So energy is the ability to do work, which means the ability to move something. Okay, now energy has two forms. It could be potential energy or kinetic energy. Potential energy is energy of position. So if I lift up an object, or I stretch out a spring or rubber band, I'm talking about position. Kinetic energy is energy of motion. We'll go into more detail another time about kinetic and potential energy. What I want to talk about today are the units of energy. The most common unit of energy used in physics is called the joule, okay, which is abbreviated capital J. Now, what is a joule? 1 joule of energy would be the amount of energy it takes to lift an object with a mass of 100 grams to a height of 1 meter. Okay, so I lift that object up. How much energy have I put into that object? That would be 1 joule. Okay. Another unit of energy that's commonly used is the calorie. Okay, now a calorie is equal to approximately 4 joules. Okay? Now you've probably heard of calories, which we use to measure the energy stored in food. Actually, the calorie that we use in food is actually a capital C calorie, also known as a kilocalorie, or 1,000 little c calories. Okay? So 1 calorie that we use in food is equal to approximately 4,000 joules. Okay, and if you remember that 1 joule is the energy it takes to lift a 100 gram object to a height of 1 meter, then 1 kilocalorie would be 4,000 of those. Okay, so it gives you a sense of what that is. Alright, before I get into some other units, I need to tell you about another idea called power. Power is the rate at which energy is used. And remember that a rate is something over time. Okay, so if something's changing over time, that's called a rate. We often use the rate that you're probably most commonly used to using is speed. Speed is the rate at which you cover a certain distance over time. So power is the rate at which energy is used over time. So we might say power is energy used over time. Okay, and the unit of power is called the watt. So 1 watt is equal to 1 joule per second. Okay, so 1 watt is 1 joule per second. Consider for a second a light bulb, a 40-watt light bulb. How much power is a 40-watt light bulb using? That's 40 watts. How much energy is that consuming every second? Well, 40 watts means that every second 40 joules of energy are being consumed. All right, and so forth. Okay. So how much energy would be used by a 40-watt light bulb over an hour? So over 1 hour, a 40-watt light bulb would be using 40 watts, which is 40 joules per second, times was 3,600 seconds in an hour. So we would multiply 40 times 3600 to get our answer. And that would equal, running out of space here, 144,000 joules. So that is the 144,000 joules. That's the amount of energy that this light bulb would use in 1 hour. Now, the electric company has a funny way of measuring energy. So energy used in homes through electricity is measured in a funny unit called a watt-hour. Now remember that watts are a unit of power, and hour, of course, is a unit of time. And if you remember that power is energy divided by time, energy is power times time. So there we go. A watt-hour, power times time, this is actually a unit of energy, not power. It's a funny unit because it has this power unit in it, but it turns out that a watt-hour is a unit of energy. Okay, so 1 watt-hour is the energy consumed by a device burning power at a rate of 1 watt, or 1 joule per second, for 1 hour. Okay, so how do we figure out what that is? If 1 watt-hour, remember, is 1 joule per second, because that's what a watt is, times hour. Remember that there are, or you may not know, but it turns out there's 3,600 seconds in an hour, because there's 60 seconds in a minute. 60 times 60 is 3,600, times 3,600 seconds in an hour. Okay? So 1 watt-hour is equal to 3,600 joules, because in 1 hour you will have used 3,600 joules if you are burning energy at a rate of 1 joule per second. A little confusing, but if we remember this, that will help us enormously. Another unit of another unit of energy is called the BTU, which stands for British Thermal Unit. British Thermal Unit, it turns out, is the amount of energy it takes to heat up 1 pound of water by 1 degree Fahrenheit. It's kind of an obscure unit, but picture 1 pound of water. And if you think that a gallon of water weighs 8 pounds, about 1/8 of a gallon. So raise 1/8 of a gallon of water, 1 degree Fahrenheit. That's 1 British Thermal Unit, or BTU. And 1 BTU is 1,055 joules. BTUs are often used to measure the amount of energy in heating and cooling systems. A really obscure unit, which you will see on your natural gas bill, is called the therm. Okay, and the therm is really confusing. A therm is approximately the amount of energy it takes to burn 100 cubic feet of natural gas. Okay, so a cubic foot, 100 cubic feet is, picture a cube, 4.6 feet by 4.6 feet by 4.6 feet Okay, so probably a little shorter than U on all sides. Fill that with natural gas, burn it, and you would get 1 therm. Okay, and a therm is approximately 100,000 BTU, or 105,000,000 joules. 105 million joules would be 1 therm. So there we go. We've got several units of energy. We've got joules. We've got calories. We've got kilocalories, which is capital C calorie. We've got watt hour. We have BTU, and we have therms. All of these are measuring the same thing. They're all measuring energy, which is the ability to move something. As we get into exploring how much energy is stored in different fuels, we're going to just remember, whatever the unit is, we're just measuring how much energy is stored in the chemical bonds. When we break them apart, how much can we move something?